Lecture 12: Virtual Reality Peripheral Network (VRPN). VRPN is a network transparent interface that facilitates the interaction between application and interactive devices for virtual reality. It's a complete solution to solve the problem of interconnecting devices and handling different drivers for different operating systems. Currently, VRPN are hosted at GitHub, and it has an interesting web page called vrpn.org. VRPN was designed and implemented at University of North Carolina at Chapel Hill and presented in a conference in 2001. Later, Sensix integrated two open source virtual reality projects. Sensix is a company that develops high-end head-mounted display, but now is involved in the open source community through the OSVR project. And now VRPN is maintained by ReliaSolve. This picture depicts a typical scenario of use of VRPN. The trackers, the data globes, and joysticks are connected to a VRPN server, and a client uses the TCP/IP network to access all this information to handle all the actors and objects of a VR application. The server and the client could be running in the same computer, but for a better performance, the server could be a different computer, and of course it can be a computer for the trackers, another computer for the data globes, and another computer for the joysticks. So an MVE could be easily integrated to this environment. In VRPN, each computer controls a defined number of peripherals and handles all the connection across the network using TCP/IP. The client doesn't need to know how is the network or where are located the servers. So this helps to distribute the load across all the hosts. VRPN supports a large number of devices. For instance, the Kinect, the Phantom Omni, the Nova Falcon, joysticks, gamepads, keyboard, and several trackier devices. The peripheral data includes the numerical and logic data for translation, rotation, and button pressing. VRPN has three types of entities that handles all the peripheral information. The tracker type holds a position and orientation. The analog type is used for any analog information like the axis of a joystick, the position of a mouse, or any analog variable. The button type is used for a kind of binary information like the joystick button or mouse press of any button. A tracker is a device that has position and orientation in a 3D space in a defined number of degrees of freedom. For instance, the Razer Hydra that is shown in the picture has the following information: position and orientation of each control, and the button pressing, and the joystick position. A VRPN analog type usually handles information between 0 and 1. For instance, a mouse could be used in a VRPN analog entity where the coordinates 0, 0 are in the upper left corner and 1 are in the lower right corner. VRPN button is an entity using binary information, 0 or 1. So one can design a device with 3, 4, 5 or any number of buttons, and each one could be handled using a VRPN button. This is an example for VRPN where the user can use the keyboard and mouse information and send it to another host. In this example, we will use the same computer for both server and client. First, download VRPN binaries, uncompress the zip file to the folder shown in the slide and locate the VRPN CFG file and edit it using a text editor. Look for the VRPN mouse line and uncomment it. Later, we have to run the VRPN server. The server launches a window without any information. Later, we have to use the command prompt program to go to the directory and run the VRPN client. For this example, our client is called vrprintdevices.x, and we have to type the name of the device that we will use for VRPN. In this case is mouse 0 at localhosts. In the window of the client, there is the information sent by the server, and also the server shows an information about the client connection. For using the keyboard in the VRPN CFG, it is necessary to uncomment the following line and close and run again the VRPN server. So this time we will use the VRPN print devices using as a parameter keyboard 0. You can create two windows, one for the mouse and one for the keyboard. In both cases, the client are connected to the server and are requesting the information of the assigned device. In order to access other hosts in the network, one can replace the IP address or the host name. For this example, we will use 170.0.0.1 to refer as a local host. Local host is the name used in the computer network environment to refer to the same computer. But if you know the address of another host hosting a server, you can use the address like the example shown on the screen. A custom VRPN client could be written using C++. For this case, the VRPN analog remote could be used to handle the received data, and it is necessary a callback function that will check every time in the execution loop for the changes in the analog remote variable. You can check the website vrgeeks.org for more detailed information of the examples of VRPN client. To write a VRPN server, it is necessary to write a class for the required type of device that we will use, like the VRPN tracker, VRPN analog, or VRPN button. A custom server could have a mix of all of these three classes. A main loop function is required to check the device values, the device information, and prepare it to send it to the client when it is requested. And finally, VRPN could be integrated to Unity using one of these plugins. So it is very easy to configure a client in Unity to access information in another server. For instance, a server could be right in order to access the information for a Arduino board using its digital inputs and analog inputs for button or analog information for VRPN, and using this plugin could be integrated easily to a Unity project.